we discuss the uh, all exam related question, and whatever I do the research on any social media platform, I will hmm, show that in the live session like this. And uh, today is our data structure exam, so I am going to uh, revision do some revision of a related question and some important question regarding exam. So here I give the notes of a list of questions to the chat gpt, and I said him to give a proper answer so that I can uh, write it in the examination. So let's see our first question, uh, that is about array and its type. So array is a linear data structure that store multiple elements of the same data type. It is the linear, not a branched like tree and graph. If you go to the tree, they are not linear. They are hierarchical, they are non-linear. There are several branches occurs in any tree and graph like data structure, but uh, that uh, property is not possible in the array. Array is a single directional, it is a linear. It stores multiple element of same data type, and also it can't store the data type of several, like it you can't store in an array like integer as well as character as well as float and other type of data type like double int long. If you have created a uh, uh, array, you can only enter in only one type of data, like you can see here in the example of 1D array, the in the code section, the data type is uh, in the form of int only, and all the values that are initiated in the array of size 5, those all are just int. So the all data type are same. In contiguous memory location, and it also store those all data in contiguous memory location. Contiguous means what? Continuously, not a fractional difference, but it store each and every data in the memory locations of a specific of a constant space. Firstly, suppose I have stored my first data in the memory location 101, and the second data in 103, then the my third data will be stored in the 105. I have make the gap of 2. So like this format we store the data in contiguous memory location continuously for the array. Elements are accessed using index starting from 0. So array, in array you have to access the elements. Means if you want to display got any element from the array, list of array, you have to use its index, and in array every index start with 0. So type of array, there are several types of array, like one dimensional array 1D stores any element in a single row. Example is below. Int a5, two-dimensional array 2D array stores data in a row and column. It also known as the matrix uh, dimensional array. Example is below, and here we just take the two sizes, one for the column row. Firstly we take the row, that is the horizontal line, and the second one, the size we take for the column. So in the entered value, we can easily see there are two here, not it is uh, designed like a matrix format, but it has represented in the linear format, but it is not actually the linear, because why here it is uh, written as a linear format, because everything that we store in any memory, it directly or indirectly goes to the in linear manner, non in linear manner, because memory stores each and every data in a v9 format, and v9 format is a vertical format of memory location, and that is absolutely linear. So no memory stores data in a uh, several or multi-dimensional format. That's why here it is written in the linear format. So you can easily see the lines are 2, the size, the numbers of rows are 2, and if you assume the elements are in the set of 3 in the both of the set, both of the column. So column 1 3 element 1 2 3, and column 2, not column, row. In first row there are 3 element, 1 2 3, that makes 3 columns, and in the second row there are 3 elements again, 4 5 6, they makes the uh, form the 3 rows and 3 columns, 1 2 and 3. Multidimensional array with more than 2 dimensions are called multidimensional array. Array as pointer, array behaves like pointer as well. hmm. In C, array name acts as pointer to the first element of the array, and we know that the first element of array is nothing but the index 0, because we know the array's first index is 0, means also it acts like a pointer. So you can easily say that this is the first uh, um first element of the array, and it is pointing to the 0 index. So here there is an example int a, array of size 3 in which 10 20 and 30 are the numbers, and when we print to the uh, um, pointer a, so it will print what, 10. Fine. Pointers, array name stored the address of the first element, and why it is printed only 10, because array name stores address of the first element only, that's why the we got in output only 10 here. Pointers, points, array name stores the address of first element. Fine. Int array I is the same as the pointer of a plus I, means it is increasing in the a with the increment of I value. Array name is constant pointer. Next is function parameters, actual and formal. We know that there are two parameters, and the parameters are what? The parameters are nothing but the variables, or constant. So actual parameter, values passed during function call and present in the function call is called the actual. The value actually we provide in the function call, during the function call, that has been already defined in any code, and for accessing that, when we call any function, like here in the example the sum is calling in 10 and 20. Here 10 and 20 are actual parameter, the value that we actually provide to the function. And the formal parameter, variables that receives value present in the function definition. In function definition we can say, see here easily, void sum. When we are defined the sum function, we defined or initiated two variables uh, with that, that is a and int b. So these a and b are formal parameters, that that receives the actual value that we provide in the calling function. Calling a function, how we can call function. So there are mainly two types of calling function: call by value and call by reference. So what is call by value? Copy of value is passed, original value is not changed, and that is called call by value. So we can see here in the code, void change is called, in which int x and x is uh, initiated with 20, and call by reference, uh, actually what we do in the call by value and call by reference. Call by value says, yes, I will give you the value, uh, but not I will provide you the actual value. I will provide you the copy of that value. Means here in a specific memory there is a data. So I will not provide you that data, that that memory will be become empty. No, I will make a alias, a copy of that, and that copy will be provided to you. Means if you do perform any uh, changes or anything, any operations on that uh, by using call by value, that will not affect the actual value, that will only affect the copies value. You can not affect the actual value of the function of the variable. You will everything perform in another copy value that will be the on the different memory location. But in the call by reference, we uh, perform every operations and every uh, uh, thing on the exact same data. So call by reference, address is passed, original value is changed. So already we have passed the address, means your the data is available on this address. So we can easily change it, we can easily make different operations on that. So that's why we said the calling of function is can't change the actual value, because here we don't providing the address of the exact same data, just we are providing the copy of that data. So you can, if you want to perform any operations on that data, you have to perform on the copied value, not the actual value. But in the reference we are providing the address. So if already you have got the address, so what will you do? You will change the value, or you can perform any operations, like here void change int asterisk s asterisk 20. Means in this code it is it is saying that that I want to change in int asterisk s, means एस्टेरिस्क एस लोकेशन पर मैं 20 को इंसर्ट कराना चाहता हूँ, जबकि पहले कितना था यहाँ पे, ऑलरेडी 10 था या कुछ था, मतलब सपोज कुछ और कुछ भी वैल्यू हो सकता है, तो वहाँ पे मैं क्या कराना चाहता हूँ, 20 को इंसर्ट कराना चाहता हूँ। तो ये हो गया, हम वैल्यू को चेंज कर रहे हैं बाय यूजिंग कॉल बाय रेफरेंस। नाउ वी कम टू द रिकर्शन एंड रिकर्सिव फंक्शन। ए फंक्शन दैट calls itself is a called a recursive function. The function that calls itself is called recursive function. Must have base condition. Base condition is what, where the code will terminated. It recursively calls itself again and again, again and again, but there will be some condition where the function will be terminated, will terminate. So the that termination will be provided in the any recursive function by the base condition. So the base condition is a most important thing in the recursive function. Use a stack memory. It uses a stack memory to store the data that was produced by calling itself recursively, or the function that is defined in that recursive functions. So those all data were stored in the stack memory. We can easily see here there is a function that is fact, means factorial int n, and if n equal to 1, return 1, and return n into fact n minus 1, means what, here return n into fact n minus 1 is nothing but a type of no. So base function is here, if this is the base function, if n equal to 1, equal to 1, return 1. This is the base function of this recursive function, and here that we uh, performing over all this operation, that is the recursive function, because we can say in the return n into fact n minus 1, means it will recursively uh, give the value of n into fact n unless or until the n will become 1. So this is very easy. Now we see the static versus dynamic memory allocation. So static there are two type of memory, static and dynamic. Static means you can only uh, define the size of memory during the during the writing code or program. You can change at the runtime the size of memory, but the in dynamic memory you can change it in the runtime. So in the static memory it works on compile time, but dynamic memory works on runtime as well. Static memory has fixed size, but the dynamic memory has a flexible size. It uses the heap memory to fluctuate its size. So in the below it is mentioned, static memory, stack memory, it store in its data in the stack, but the dynamic memory uh, stores its data in the heap memory, that can be changes or extended, his can be extend and can extend his its size by using all the dynamic memory allocation functions like malloc, alloc, realloc and free like functions. So these all are mentioned here in the below. Dynamic function that are used to uh, the dynamic nature of the dynamic memory to that helps in the flexible size. Those are none other than the malloc, calloc, realloc and free. In static, auto deallocation means if you have to deallocate the memory, it can be automatically done in the static memory, but in the dynamic memory you have to do manually, and you have to free it manually by writing the free PDR. So here is array versus linked list. What is the difference between array and linked list? So array is also a data structure, data type, in which we store data in the contiguous memory location, and those all are of same data type, and fix the memory that is used in array, that is of fixed size too. But in the linked list, and array is also a linear data um, structure. But if you talk about linked list is to uh, a linear, non-linear, non-linear. We can't say linear. No, it is also linear, but it is not contiguous, not continuously store the data of a specific address by having a specific or constant space. In linked list, you can randomly access the data of different locations, but you have to link it with the uh, hmm, its next node that store the data of the next node. So in linked list, mainly there are two section are found in its node. One is data part and the another is uh, address part. In data part, we put the actual value of the that same node, but in the address part we put the address of the next node in which we are going to approach. So in that, again, that same that the next node have two section again. One is for the value, for its own value, and the another section that will be for the address, and here the address will be a store of the next node again. So like that manner, linked list make a huge and a linear a data structure in non-contiguous format. So you can easily see array is a fixed size, linked list is a dynamic size. Array is contiguous memory location, but linked list is non-contiguous memory location. In array it is faster to access, but the linked list, it is slow. Why it is slow? Because we can't access the any specific value in the linked list. It sequentially access the each and every data, data of the linked list. You can't directly access the any specific data from the linked list. It will start from the head or the node 1, and it will go from node 1 to 2, 2 to 3. Why? Because here there is not a structure like array. Array have a specific distance or a specific or a contiguous address that is always starting from 0 index and goes to with a specific space, but that phenomenon is not an that property is not available in the linked list. So that's why linked list how traverse in its nodes and its all the series one by one, it because if you are saying I have to go directly to the fourth node, how will go? Huh? If you have to go to the fourth node, firstly you have to go to the third node, because the location of fourth node is available to the third node, and if you want to go to the third node, you have to go to the firstly second node. Because why? The location of third node is available to the second node, and if you want to go to the second node, firstly you have to go to the first node, because the address of the second node is available to the first node. That's why the accessing in the linked list becomes slower than the accessing in the address array. Fine. Insertion costly. If you want to insert any array, it is quite hard and quite costly, because you have to arrange the all defined uh, locations, and you have to adjust all the indexes with its necessity. But in linked list, you bring any data from anywhere and you can insert the at the end of and the beginning of and even in the mid of the any linked list. It is quite easy, so insertion is easy in the linked list. Fine. Now we have linear and non-linear data structure. So linear elements arrange sequentially. Example: array, stack, queue, linked list. Huh. So this all goes in a sequence manner, huh? Not random. Sequence means one by one, not a fragmented manner like a tree and graph. You make branches from one node, several, you can generate several branches, so that is not possible in linear. So elements arranged sequentially, for example array, stack, queue, list. And non-linear elements arranged hierarchically, श्रृंखलावत तरीके से इसमें बहुत सारी शाखाएं निकली होती है ट्री एंड ग्राफ में। अब आता है कुछ फंक्शन। पहला है साइज ऑफ, टाइप डेफ, मैलॉक एंड फ्री। साइज ऑफ return size of the variable or data type in the bytes. Type def, create alias name for data type. We have already discussed this in the structure. For any specific structure you can use this function. This is the most important, one of the most important function that is used in data structure and structure. So if you want to create alias, a little alias for a bigger name of a structure, so you can use this type def function. malloc allocates memory dynamically, dynamically uninitialized, but it's not initialize the values, malloc, but you go to the calloc. It is similar like something, but calloc initiate the values with 0. So allocate memory dynamically. Free is used for releasing the allocated memory, the memory that you have already allocated with the several data and the list of data. You can use the free function to reallocate and release all the allocation and allocation of the memory. Singly linked list versus singly circular linked list. Singly linked list and the singly circular linked list. In a singly linked list, last node is null. We know because last node have no address of any node. That's why its address part will be the null. So that the same thing is saying is said here, that the in a singly linked list last node will be the null. In a singly circular, last node will contains the which first node. First node. Why? Because in singly circular how it works, it works like something like this. You have not, but how can I do this? There is no feature that I can convert it or show you my, but I can easily help you to understand, not visible quite. So I can explain properly. In a singly circular linked list,